Okay, so um, here we've got just sort of a kind of catch-all picture, kind of showing you the different kinds of inequalities, and then the way you would write those as intervals. There's also this thing called set builder notation, which is not used quite as often, but it's a thing. Um, so anyway, if you go from one point to another, like 5 to 10, the 5 has an open hole, a circle there, it's a hole. So the 5 is not included and the 10 is included. That would be written as 5 less than h less than or equal to 10. So basically the 5 is the smallest value, which is why it's less than. The 10 is the biggest value, which is greater than. And then the equal to line is there with the 10 because it's filled in. There is no equal to line under this one with the 5, which is why it's an open circle there. And then the way that interval is written is you have 5 with a parentheses and a 10 with a square bracket. This one is just the reverse of that. Here the 5 is included and the 10 is not. So the 5 has a square bracket, the 10 has a parentheses. Here they were both excluded, so they both have parentheses on either side. Here you've got everything from 10 all the way down. That's negative infinity to 10, both with parentheses. Notice this is an open circle, so you use a parentheses. Here you have everything from 10 and above. So with 10, it's filled in. You've got a square bracket. Everything above that to the right, that's to infinity with a parentheses. Infinity always gets a parentheses or negative infinity. And then here, there's 5, there's 10, and you notice it's actually the entire line. So it's just all the real numbers. And there's this kind of scripted R with like a extra wide line like thing. That's as an interval, that's negative infinity to positive infinity, which just means everything. So that's kind of a useful kind of reference chart, kind of showing you the different ways that the number line and what that looks like is an inequality, and then compared to what the interval notation looks like. There's also this thing, set builder notation, but it's not nearly as commonly used, but it's there it is. But okay. Another way to figure out the domain and range is if you just have a picture of the graph of a function in front of you. And in my opinion, at least, this tends to be a lot more straightforward, because if you have a picture right in front of you that you can look at, then finding the domain and the range is pretty straightforward. So the domain is all the possible x's. So what that means in terms of a picture is just how far from the left to the right is the graph going. So this thing in the dark blue, that's the actual function. The domain is all the possible x values. So the lowest x value for this picture, the domain in this instance, the lowest it ever goes is -5. And that is included there because you see that's a filled in point. So from -5 to infinity, that would be the domain of this particular function. The range is the possible y values, which is another way of saying how high up or down does it go. So this would be like negative infinity for the x's. This would be positive infinity for the x's. For the y's, this would be negative infinity down here. This would be positive infinity up here. For the y's, which is the range, we'll do that in blue here. For the range, the lowest it goes is negative infinity. And then the highest it goes is, this is at the 0.5. This one was at -5. This is at 5. So the highest y value is 5. And again, that is included. So if you have a picture in front of you, that is how you would describe the domain and the range for that particular picture. And again, we've mentioned this before, but just to reiterate, the domain is all possible x's. And that's basically saying from left to right, how far does it go? The range is all the possible y's, which is another way of saying down to up, you always start low and go high. So that's down to up. Where does the graph go? So that is how you describe the domain and the range. So here they say, find the domain and range of f of x equals negative square root of 2 minus x. So what we are going to do is we're going to graph this function. So if you've got yourself a graphing calculator, if you turn it on, up here, there's a y equals key. It's right above second. And then in the very first one there is where we will graph it. The equation was negative, so you got negative right here. Don't use the minus sign. Minus and negative do mean different things to this calculator. If you want the square root, you've got the x squared key. So you do second x squared, and that would give you the square root. So second x squared gives you that right there. And then what was it? 2 minus x is what it was. Negative square root of 2 minus x, okay? So you'll see there, I'm underneath the square root symbol. So I'm gonna do 2 minus, to get x, you use this button right here. It's right next to alpha. It's got x, t, theta, and n. It's got all these different variables here. So this is basically the button you want to get x. And then if you push enter, so that's the formula there. That's how it's written on the page. That's how it is on the screen. If you look on the other end, you'll see the graph button. So if you push that, it'll draw a very lovely picture of what that graph looks like. If you push the trace key right next to it, it'll even give you some coordinates there. So it's got that value there. The y-intercept, you can use the arrow, if I can find them, you can use the arrow keys to kind of move back and forth here. And there you'll notice it's undefined because it only goes so far. And you got like over there. What you'll notice is that you can see that it hits it there on the second tick mark, which is at -2. So what I'm going to do is draw a rough sketch of what this graph looks like. So, so over here at -2, that's where it starts. And then it like curves down and goes like so. So that's at -2 right there. And then it kind of curves off and goes that way. So we want the domain and range of this graph, and then having a picture in front of you makes this a reasonably straightforward task. So the domain is from side to side, it's all the possible x values. So the lowest it goes is -2, and it goes as high as it wants. This point right here is -2, 0. So the lowest it goes is -2.
Professor Husky, we can't see your screen.
Oh, geez. Okay, sorry, sorry. Thank you for that. Okay, let's see. So there's a very rough sketch of the picture that was on the screen of the graph there. So as you can see, there's the -2, 0, and it kind of curves off that away. So the domain, the lowest possible x value that we have, inclusive, the lowest it goes is -2, and then it goes as far to the right as it wants to. So there you go, it's -2 to infinity, and you put the parentheses there. For the range, this graph goes down forever and ever, so there's no limit to how low it can go. So this can go as low as -infinity. The highest y value that you have with this particular point, the y value is 0. So it goes up to 0 inclusive. So that would be the domain and range of that graph. And again, if they give you a formula like this, getting a picture of a graph in front of you so you can kind of just look at and see what you're dealing with is the most straightforward way to do this. And so this will be a good way to get acquainted with how you can draw graphs using the graphing calculator. But that is how you would do one like that.
Hello, is this -2 or +2?
It should be negative, or let's see. It should be +2. You're right. I'm looking at a mirror image of the graph, so yes, thank you for catching that. Let's see. Because Zoom gives me a mirror image of myself, so I'm actually looking at it backwards. All right. Good, well observed. It should actually be +2. Let's try this again, shall we? So this is, let's see. So it actually starts over here at 2, 0. And then it actually curves off the other way. Because that's, okay. And so actually, let's see here. The domain, all right, that's actually going to change this around here. So in some ways, I think I would prefer Zoom showing me what it's actually supposed to look like instead of showing me my own mirror image, because that's what I would be accustomed to looking at when I look at myself. So it goes from -infinity to 2. That looks a lot, okay. This is from -infinity to +2. If you go from left to right, and then the range is -infinity to 0. So, okay. Yes, so it's actually over there at +2. Okay. Let's see. So what else do we have here? Here we have a piecewise function. So these graphs are kind of challenging. What you'll notice they give you a domain for each section. So depending on which values we are talking about, we're going to use a different formula. So what you will notice, here's what I'm going to do to start things off. You'll notice that the first change happens at -1. So I'm going to put a boundary line right here at -1 right here, because that's where I'm going to change from one graph to the other. Here, the middle section is -1 to 4. So I'm also going to put a boundary line here at 4. And then the last part is basically everything that's going to be above 4. So here's how I'm going to do this. I'm going to make myself a table of values. Now you notice here, this is -1. I'm gonna go a little bit below that. I'm gonna go to the value -2, which is just to the left of -1. So if I do -2 and raise it to the third power, because this is going to be, we'll call this top, middle, and bottom, just to call them something. So here we use the top equation. So you do -2 to the third power. If you work out what that number is, you end up with -8. So the first point on this graph will be -2, -8, which is going to be this point right here. Next up, I'm going to do -1. Now, -1 is where it's going to transition from one graph to the next graph. And so I'm actually going to do this twice. I'm going to do this once using the top equation. I'm going to do -1 to the third, which is -1. And then I'm actually going to do that again with the middle equation, which for the middle equation, it just always equals -2. There's no formula there. It's just for the middle section of the graph, it always equals -2. Now this would be a solid filled in point for this one, because like any point that you ever graph, you always fill it in as a filled in point. The thing to see here, this is less than -1. So that's going to be an open circle at that point for the top, because it's going to get close to that value, but it's never actually going to equal that value. So I'm going to have the point -1, -1, and that's actually going to be an open circle on my graph right here. I'll have an open circle right here, and then I have a curve basically going from there to there. And then it's going to kind of keep on going down forever. Now for the middle part, it doesn't equal -1. So this is also going to be an open circle. So at -1, we're going to be at the value -2. For the middle section, it's going to be flat. It's always going to be at -2. And it's going to keep going until it gets to 4. So you'll basically have a section of a horizontal line right there. So the next number I would do, like if I was making a table, is I would have 4. This would be from the middle, which is also -2. That'll be an open circle. And then lastly, for the bottom, I do the square root of x. So I'm going to do 4 again. This time I'm going to use the bottom equation. So that would be the square root of 4, which is equal to the number 2. And again, this is a greater than symbol. It is not equal to. This would be an open circle right here. So at the point 4, 2, so 4, 2 would be right there. You'd have an open circle right there. And you'd have that graph right there. Now for the bottom, I could do other values too. Like I could put in 5. The square root of 5 would be this kind of icky decimal. Same with square root 6, 7, or 8. So what I'm going to do is I'm actually going to pick the number 9 for the bottom equation. And the reason I'm picking 9 is because if I do the square root of 9, I get a nice round 3. And then that value, that would be an ordinary filled in point like normal. So if you go over here, you're gonna have the point 9, 3, and you end up with the last chunk that's like right over there. So that then is a sketch of what that piecewise function would look like. You've got part of a x cubed graph curve. You've got a flat horizontal line at -2, and then you've got part of a square root graph starting at 4 and then going off to the right there. So that is a sketch of a piecewise function. And it's called piecewise because it's got 3 different pieces. That's where that name comes from. Okay. So that is the end of section 2. So next we're going to go on to section 3.